Okay, so the big overview of techniques of integration. The number one rule of techniques of integration is look for the simplest technique first. Save yourself some time and mental effort and do this. So what's the easiest possible integration technique? It's a known formula. So for example, you have to know off the top of your head that the integral of 1 over 1 plus x squared dx is arctan x. Because if you don't know that, then you'll try to go through all these different possibilities of, can I do it this technique, can I do it that technique? But it's just a known formula, and that's an integral you should be able to do in 4 seconds, for example. Okay, number one. Number two, substitution. If it turns out the integral is just in the form of u squared du, but u is really, really fancy, if you can just do that u sub, then immediately you've got an integral that's very easy to do. Okay. And we've seen a lot of u substitution problems. Okay. The next one to check for, a standard form for one of the techniques, a basic form for trig sub. Square root of 1 minus something squared, that something should be sine theta, or sine t. Okay, for example. Partial fractions. We know what typical partial fractions look like. Got a polynomial divided by a polynomial, with that polynomial in the bottom factors. Okay. Integration by parts, we've talked about that. And we talked about the rules when you do integration by parts. So for example, the integral of x e to the x, that should jump right out as integration by parts, because you want to differentiate away that x. Okay. Integrals of trig powers. We talked about the rules for these. If you've sines and cosines, odd power of sine, you know exactly what to do. So those basic types. Okay. And then number 4, the catch-all, something harder. So if it's not a standard kind of thing that falls into 1, 2, or 3, then you have to do a little bit of work. Okay. So my general advice to you is assume that every integral is easy until easy methods don't work. This will actually save you some time, because a lot of the integrals that you have actually are designed to be easy. And the trick is which technique that you've learned actually works. So you should go in with confidence knowing that something that you know works, and you just figure out which one. So if you're going to try to figure out which technique works, check the easy technique first. It's much easier to try an easy technique than a harder technique. So check that first. Et cetera, et cetera. Okay. So there is a sheet where you can work on many, many different kinds of integration problems. But I want to give you an additional exercise to do, and this one is really like doing integration. This is like an integration power workout. So it's the following thing. Let's try this exercise. Take a straightforward integral, then make it harder. So for example, we know that the integral of cos x dx is sine x plus c. Easy integral. Now let's turn this into a hard problem. Replace x with something. So instead of x, let's make something up. So I'm going to say e to the t. So if x equals e to the t, then dx equals e to the t dt. Now rewrite that statement. When you rewrite that statement, you now have the integral of cosine of e to the t times e to the t dt equals sine of e to the t plus c. This is how an instructor, for example, makes up hard problems. You start with something that you know and just make it look fancier, for example, through a substitution. This is a great, great exercise to do. And I've got another example here. But what I suggest, if you want to do, like I said, an integration techniques workout, is pick an integral that we know how to do, then replace x with an expression in t. Make it into a harder integral that suddenly you know the answer to. And this is a great way to study techniques. It trains you to see when there is a complicated integral, what is the simpler integral that is hiding inside. Because believe me, I know that techniques of integration is hard because you don't know which technique to use. So an exercise like this, for example, trains you to see what technique you need to use. By doing problems in reverse, it makes you better at doing problems forwards.